All right, everybody, welcome back. If you're here, I can give you your test later on. We can add a break or after class. If you're not here, I would recommend trying to come to class from now on because the internet has been going out kind of spottily for the last 3 weeks or more. And if the internet goes out, Zoom goes out, and the recording stops, and I'm not doing the lecture twice. So you take your chances of doing it at home. You might have to watch someone else's videos or something like that if it doesn't record here. We were in 4.5, optimization problems. And quick recap. Read the problem thoroughly. Identify what is known and what you want to find. We went over this on Tuesday, or whatever day we did it. Tuesday? Feels like it was Tuesday. Draw a picture, label shit. And list any relations you can see. Or formulas you know. Or need to look up related to it. C, manipulate the formulas / combine them. Until you get your unknown is the only thing you don't know in the equation. YouTube, I don't want to watch fucking videos on my phone. Annoying. E is for derivative time. Take the derivative, find your critical points. Test for max and min. All right, you guys ready for a problem? Get up for one more minute. Can you guys see the screen fine? Or is it too bright up here? Sometimes that light fucking throws it off for the people in the back. And there's fucking 4 light switches in the back, and there are 4 rows of lights. And you would think 1 light switch per row. Nope. You gotta flick off 2 of them together to get 2 rows to go off. They don't go off one at a time. I don't know. All right. Let's take a look at an example. And I haven't worked this one out yet, so we're gonna have fun on this one together. An open top box is to be made by cutting out small congruent squares from the corner. From the corners of a 12-inch by 12-inch sheet of tin. And binding up the sides. What size squares should be cut to maximize the volume? That's not even how the word problem. The problem says it to make the box hold as much as possible. Make sure you get it written down. We'll do a picture. We gotta figure out what's going on here. The general idea is like we can fold up corners on the paper. This is my sheet of tin here. And we could try to make a box, but like these corner squares are getting in the way of lining up that side and that side. Like that's what needs to happen. And I didn't fold it square, but if it's square, the height matches and everything, and we'll have a box. Does that make sense? Something you can picture? So I don't know what size corners these are gonna be. But that's what we want to cut out. This whole thing is a square. So, and then they said small congruent squares. So like if this little piece right here is X, that's X. That's X, that's X. X, X, X. So if we fold up the box, this is going to be like the base of the box. What will the side lengths be? We know the whole side, and it's the same on any side, is 12 inches. What does that gotta leave for this part right here? Twelve minus 2x, right? We cut out an x up here, we cut out an x up here. This should be 12 inches minus 2x inches, or 12 minus 2x. And it's a square, so it should be on the same on right here too. That should be 12 minus 2x. All right, we're making some progress. We've identified what we're looking at. We've drawn a picture, we've labeled shit. What's the equation for the volume of a box? What? Yeah. V equals LWH, length times width times height. That's 3 variables. We don't like that, but if this is our length and this is our width, what's our height? X. When we fold it up, these are going to be, that's going to be the height, because that's what we're folding up. So we have 12 minus 2x times 12 minus 2x times x. Now we've got the volume in terms of x. Now, I'd probably write it. I'd probably make my work a little bit easier, factor out a 2 out of each of these. And then rearrange it to say 2 times 2 is 4x, 6 minus x squared. All right, we've got an equation. What do we do to find how to maximize it? Let's find the what? Yeah, how do we do it? Well, we know if it's like 0 inches tall, there's no volume. And we know if it's like 6 inches tall, or I don't know I don't know what size we'd have to get where, like, if we folded the paper completely up, the corners take up all the page, it'd also have a volume of 0. This is at least somewhere, well, we see it's a cubic. Part of it's got to be going, there's got to be a max somewhere. It's a cubic, there's got to be a max somewhere. How do we find maximums?
We said it was
Set what equal to 0?
volume equation.
We set the derivative equal to 0. Set the derivative equal to 0. If we set this equal to 0, we can find, we'll take a look at that in a second. Well, we'll find where the volume equals 0. Because we're setting v equal to 0. We don't want the volume equal to 0. That's exactly what we don't want. So if you're like, I don't know which one to set equal to 0, stop and think about what we're doing. If I set this equal to 0, am I optimizing the volume? No, I'm actually finding the minimum volume. So we want to find the maximum. It's probably at some peak. This fucking shitty blue pin cap. Fuck you, pin. You might as well use it till it's dead. All right. Help me with the derivative. Go ahead and find that derivative, and then we'll do it together. Because product and chain rule will fucking up half of you guys on the test. So I want you guys to take a run at it, and then we'll do it together. If it makes you guys feel better about the exam, no one got 100% without extra credit. Everyone missed at least something. I don't know if that makes you feel better. I was really hoping that the student that got the 100% last time was going to continue that, but just total letdown, complete disappointment. The percentage of passing grades went up, but I think that was because the people that weren't going to pass dropped. Or some of them, that is a question. All right. So. I'm gonna slow this down a little bit. And say, let me rewrite it on this page. I'm gonna call 4x f of x, and I'm gonna call 6 minus x squared g of x. So that v equals f of x g of x. And dv dx equals f prime times g plus f times g prime. What's the derivative of f prime, or derivative of f? 4. What's the derivative of g prime? Nope, I said that wrong. Derivative of g prime would be g double prime. What's the derivative of g? Dalton.
2 times 6 plus x.
-1. Don't forget this the sign there. So got to take the derivative of the inside. Don't forget to do that. I'm going to do that step as 2 parts just in case it helps, because some people are missing this stuff, and this is like fundamental to calculus. Wow, my hands just keep cramping when I try to do that. I'm going to say u equals 6 minus x, so that g of x equals u squared. Well, g of u equals u squared. And when I do d dx of this, I get dg dx equals dg du dx. Or the derivative of u squared is 2u times du dx. Du dx is -1. So we got 2u times -1, and u was 6 minus x. So if you need to slow down and do it slower, get it right. It's better to get it right and take up more space on the page than blur it all together. Some people are taking the derivative of both and just putting them together, and that's not how it works. And then some people knew there was a plus sign in there, but they were putting a plus sign between everything, like even between f prime and g. So let's put this together. dv dx equals f prime, which is 4, times g of x, which is the 6 minus x squared. And then we got a plus f, which is 4x, times this. I'm going to put the negative, let's put the negative inside. That will make this x minus 6. Times 2 times x minus 6. All right, that's what we want to optimize. That's where we want to set it equal to 0.
Hey, Joe.
Yeah.
It's the same process of points.
Yep. That's exactly what we're doing. We're finding the critical points.
That's the first grade.
Yes. So I got 4 times 6 minus x squared plus, I can multiply the 2 times the 4. I got 8x times x minus 6 equals 0. We need to multiply this stuff out, but let's try to work smarter rather than harder. I've got a 4 on this and an 8 on this. I can divide everything by 4 on both sides. And if I do, I get 6 minus x squared plus 2x times x minus 6 equals 0. That at least makes the shit smaller. I multiply this out, this is the 36 minus 12x plus x squared. And this is plus 2x squared minus 12x. Because don't forget,
I
6
have a
minus,
question.
yeah,
Isn't it supposed to be like a -1 at like for dv/dx?
I multiplied it into the 6 minus x and it changes the signs of everything.
Oh yeah, I see. All right, thank you.
No problem. I'd rather you ask and then know what the hell's going on than rather than sit there. And while I'm going ahead, you're going, what the hell did he do? Why is this wrong? Because I know what it's like to be there and go, that doesn't look right. And I get fixated on what doesn't look right and I stop following along with what's going on. So always ask. All right. Let's group that shit together. I got 3x squared. I've got negative 24x plus 36 equals 0. These are all divisible by 3. Got x squared minus 8x plus 12. Right. All right. What's x squared minus 8x plus 12 factor 2?
X.
And so what do we get as our answers for x? All right. These are critical points. This is where shit changes. How do I find the absolute max and absolute min? Well, not absolute max, but max and min. There is an absolute because there's boundaries here. X can't be less than 0 and it can't be greater than 12. Well, it can't even be greater than 6. How do we find the max? What? Plug them in, right? We're trying to find the volume. Let's see what they get. X minus 2 is 4 squared. 8 times 16 is 80 and 48 is 128 cubic inches. We already knew the minimum was 0. A box can't have less than 0. So what's the answer to my question? What did the problem ask?
half an hour.
That is not what the problem asks. Do you write it down?
I don't know.
What size squares should be cut? Thumb.
It's like
What?
it's 2 inch big, split it up.
Yeah, 2 inch by 2 inch square corners. And you might go, does that make sense? Well, you could check it if you really wanted to know. We knew it was 12 by 12. So if we cut out twos, if x equals 2, the length on each side is 8. So 8 times 8 and then times 2 for the height. And that's where we got the 128 up there. If I tried smaller squares, the lengths would be bigger. I'd have 10 times 10, but the height is only 1 and that's 100. So smaller goes down. If I tried x equals 3, 3 here, leaves 6 in the middle. I've got 6 times 6 times 3. 36 times 3 is 108. So yeah, x equals 2 is still higher than going the other ones. Now, granted, the next thing down from 2 is not 1. When you're cutting shit, we could have had like 1.9, but for a quick, like, does this seem realistic? That's a good way of checking, does that feel realistic? Because x equals 2 seems like small fucking corners, doesn't it? It leaves 8 inches, but if we're trying to maximize the volume, that's what works. So I checked, like, does it seem realistic or feasible? So this chapter is like, or this section in specific is like, takes everything we've learned so far in calculus and actually puts a purpose to it. Like we can actually solve shit. That's kind of neat. Now, when I was a student, yeah, these problems got frustrating to fucking get right. But they were satisfying to do because I'm actually learning something I can apply. Like if I wanted to apply something here, I'm actually learning something that's applicable. So this was like a quick ghetto test. It's not a real test. That's why I called it a ghetto test. I guess ghetto is a real place. There's real things. So I guess that's not really a good way to call it. Maybe I'll call it what one of my mentors used to call it. He used to call it the quick and dirty. Quick and dirty test. It's not clean, it's not pretty, but it gives me like a rule of thumb. To me, quick and dirty just sounds nasty though. All right, you guys ready for another example? I didn't hear yes, so I'm going to assume that wasn't a no. Let's see. You have been asked to design a one liter can shaped like a right circular cylinder. What dimensions use the least amount of material? All right, write that question down, then we'll start drawing a picture. If we need to, we'll look shit up. Does anyone know what a right circular cylinder means? Besides me? It's just a regular fucking can. It's got vertical sides. It's not at a tilt. Yeah, it's a right circular cylinder is the fancy way of saying that. There's the center. The sides make a right angle with the base and the top. Other than the shape, what is the one piece of information they gave us? Besides the shape, what is the one piece that led with that? The volume is 1 liter. Does anyone have a volume on can? That's the volume of a, you're going towards this volume of a sphere. This took me the longest time to fucking really get, and it's fucking so goddamn simple. Go ahead, Dalton. It's exactly what it is. The volume is the air. It took me the fucking longest time to figure that out, like really make that connection. And it happens with so many fucking shapes, it's unbelievable. Sphere, it doesn't because the fucking diameter changes as you go up. But what's the area of a circle? You forgot that part? You knew the fucking how to get the volume of the. The fuck? You're fucking with me, Dalton. What's the height? H. We don't have anything better for it right now, right? Presumably, this is going to end up with something in units cubed. Because that's how volume works. Units cubed. So 1 liter doesn't show me any cubic units. So does anybody know how 1 liter translates to cubic some sort of units? I think I know, but I'm gonna look it up. Unless someone else actually says the same number I'm thinking. It's related to centimeters cubed. I had 1,000 in my head, so let's check. I think it's 1,000 too, but now that we have questions going on here. Volume of a liter in cubic centimeters. Thousand. All right. So we know that this should be 1,000 centimeters cubed equals pi r squared h. What are we trying to find? Minimum of what? Of what? Say it again, louder. Yeah, that's what it says, but what does that mean? Surface area, yeah. Surface area. Cause like we don't have metal inside the fucking can, otherwise it wouldn't hold anything. So like the surface area is the only spot where we actually have dimensions. We want it to be hollow. So. What's the surface area? Yeah, here you go. Actually, it's not that hard. What's the surface area? I'm gonna call it SA. Surface area for a cylinder. Now, presumably he needs to hold shit, so it needs to have a top and a bottom. Let's keep that in mind. So what's the top look like? Pi r squared. What's the bottom look like? Pi r squared. What's the sides look like? Or the sides look like?
Not like a rectangle.
It will be a rectangle. What are the dimensions? Because we could like, if you picture like a soup can and you cut the label off and you lay out the label flat, it's a fucking rectangle. Done.
Like,
Madeline.
Is it the circumference times the height?
It is the circumference times the height. So let's see how that works out. If this was a wrapper and I made like a cut right here. And I unrolled it, this part right here would be what I unrolled. So like height would be like, it's gonna be a rectangle. And length times width, but like one of the width is like H, but what's the length? The length has got to be what's going around, which is the circumference. Which is does no one know the circumference of a circle?
2 pi r.
Close. It's pi d or 2 pi r. I don't want to use pi d because I don't have a d in this. But d is twice the radius. So if I put that together, I've got two pi r h. So the surface area is, I've got pi r squared plus pi r squared is 2 pi r squared plus 2 pi r h. And this is what we want to minimize. This is fun. I deliberately did not work these problems out ahead of time because I want you guys to see the problem solving process. I have no idea what the answer is going to be. And like, I'm just now figuring out what I need to do by seeing the equations here. So if you're like, what the fuck are we doing? Where do we go from here? I just figured it out myself looking at it. Because the shit they gave me was volume. So it was easy to look at the volume and go, let's take the derivative of that. But we weren't trying to find the maximum volume or minimum volume. We were trying to find surface area. So like the piece of information was just like a restriction. I want to solve this. What I want is, maybe SA is a little bit long. Let's just call it S. Just call it S. I want ds d something. I got two variables here though. That's fucking shitty. Maybe I could show factoring out at 2 pi r. I'm left with an r plus h. And my other equation I have is pi r squared h equals 1000. So how can I take these two pieces of information and get to something like that with only one variable? This is ugly, but you've done this before, maybe not with a cylinder with surface area and volume, but you've solved two equations with two unknowns. Dalton,
Set, the power square. Like this one.
make this one into one of the variables and plug it in. I like that because we want to work with S, so we need to incorporate this into that. So, plugging volume information into SA can eliminate one of the variables. We have two choices. I could use H. If I divide 1000 by pi r squared, I get H. Or I could use R, which is divide the 1000 by pi H, and then take the square root. Which one do you guys want to use? I want to use H too. That radical, neither of them look friendly because the fraction, but the R has a fucking radical too. So let's go with this one. Now, it doesn't mean this equation is going to be pretty. And maybe multiplying this out might be the better choice right now. Two times 1000 is 2000. The pi's cancel for the H term. And I have R over R squared, which I think I'm going to put as R to the -1. Because I think that's easier to do than having it in the bottom in terms of our next step, the derivative. And now I know what I'm going to do ds with. ds d what? R. That's the variable we got there, right? Might as well do it in terms of that. So I bring the power down. 2 pi times 2 is 4 pi. Lower the power by 1. Here I will bring the power down and lower the power by 1. Make sure when you have a negative exponent that you're actually going the right way. It's not towards 0, it's down. So what does that look like? We've got 4 pi r minus 2,000 over r squared equals. If we want to minimize it, we got to set it equal to 0. We know right away r cannot equal 0, which makes sense. A cylinder of radius 0 is what, a fucking line? It doesn't have any width. So since it can't equal 0, it means I can multiply through by it. Only clear fractions if you're not multiplying by 0. If you can't be multiplying by 0. Otherwise, just get a common denominator and solve that way. Here, since it can't equal 0, it's just easier to multiply through by it. I don't like the r squared, so I'm going to multiply everything by r squared. This becomes 4 pi r cubed minus 2,000 equals 0. So 4 pi r cubed equals 2,000. R cubed equals 500 over pi. And r equals the cube root of that. $500 divided by pi. And now I'll take the cube root of that. I'm getting approximately 5.42. This is in centimeters. So this is approximately 5.42 centimeters. On a test, you actually want both answers because this is the exact answer, which is what you want to show me that you know how to get. This is the practical answer of what you would use. Because you can't measure this cube root of pi out with a fucking ruler, right? So what are my dimensions? That's what it asks us, right? What dimensions use the least amount of material? Tom? That's our radius. Bingo. That's what we gotta do. So r equals the cube root of 500 over pi, which is approximately 5.42 centimeters. Height equals 1,000 over pi over r squared. So what does r squared look like? What does 1 over r squared look like? 1 over r squared looks like cube root of pi squared over 500 squared. So we got 1,000 pi. We got the cube root of pi squared up here. And the cube root of 500 squared. 500 squared is 250,000. Now, I'm just gonna take it and rather, this is gonna be the exact answer. But I'm just gonna do 100, or not 100, 1,000 pi over 5.42 squared for my practical answer. I'm not gonna plug this shit in the calculator. That's tedious. I already got R. Let's use R. Square my answer. So this is 1,000 divided by 29.3684 pi times pi, and 1,000 divided by that. .84 centimeters. How's that possible? It's like double. Crazy, isn't it? Or is it? You are going to find as you go through problems, especially with things like the perfect size rectangle. Seems crazy to have double, right? Or h equals 2r. That's effectively what I got. Double that, you get that. Well, 2r is just the diameter. So we got the width of our can is the same as our height of our can. Width of can is the same as the height of the can. You're going to find this happens a lot when you're doing these. The perfect rectangle is going to be a square. The perfect box is a cube. For like surface area. We had the open box earlier. If it was a closed box, the open box didn't have the same dimensions, right? It had 2 by 8 by 8. But if you made the box closed, you're gonna find that you end up getting, when you solve it all, you get a cube. It's kind of weird, like the perfect things are when the things that are competing with each other are approximately the same. The width of the can is approximately the same as the height of the can. It's crazy. All right, let's see what else we got here. Let's take a 10-minute break. 5-minute break? I don't know. I think we'll be able to squeeze in one more. I thought 2, but these are taking longer than I thought because they're challenging problems, right? Okay, let's see what next is our godforsaken problem here. A youth group is planning their annual rain gutter regatta. It's got a nice flow to the name. I don't know if that's a fucking real event. That's something fucking people in Tulare, like students do in Tulare or some shit. No way, not off the description here. They must make, what the fuck? Why would a youth group do this? They must each make a rain gutter for the regatta from a piece of sheet metal. This is where it threw me off. I don't picture a youth group using fucking sheet metal, but then again, maybe fucking 17-year-olds counts as a youth group. That is 3 meters long. And 30 centimeters wide. By bending up one-third of the sheet on each side. Through an angle theta. I was about to fucking spell out theta. Holy shit. They asked El Jefe. Now they asked you, because you're learning this shit, you can figure this out. They asked you what angle they should choose. In order to maximize the volume of water the rain gutter can hold. Well, that just sounds like cheating. Asking someone proficient in calculus how to do this? This is like being in the fucking Boy Scouts and asking a fucking carpenter to make your fucking fine wood derby cart. That's just cheating. That's a project for you and maybe Dad. I don't know. Do Girl Scouts do anything like that? I don't know. Never been. I know they sell cookies. God bless them for that. Did you know they tried a new cookie last year, like raspberry something, the Girl Scouts did, and it was only through online skip sales. The idea was to make it so that young girls, young women, would become more proficient in using online stuff for selling and stuff. It was the only way you could buy this cookie. No, I don't know that a single fucking girl did it. Mom or dad always helped them with this. And the fucking cookies were always sold out like immediately, and they canceled the cookie this year. It was such a success that they fucking canceled it. I don't know why. It's raspberry something. I'm sure you could still buy a box on eBay, but if you do, it's last year's cookie, because they're not making them anymore. Everyone got this written down? This is that. All right, so we got this piece of sheet metal. And we're gonna bend it along the thirds. This is 3 meters, and this is 30 centimeters. So side view is just flat. Right? It's just a piece of sheet metal. And we want to bend it up at angle theta. So that this volume right here is maximized. Volume is max. That is so not the way you write. Let me put it below it. Maxed. I don't know why my water's green. Maybe I should have made the sheet metal green and the water blue. I feel like. And tell me if you guys feel this way. Do we really need like the whole length? Do we need to do the volume? Wouldn't it be enough just to maximize the area? I would think. Because just multiplying the height, no matter what we get for the area, the height is not changing. The height is going to be the 3 meters. Whereas the width, well. So maybe we could get away with doing the area. We could always scale it up, do the volume afterwards, make sure it works. So the question is, what do we got here? We got a shape like this. I would say we know 3 of those sides. What 3 sides do we know there? Dalton?
Bottom.
They are what? 10 centimeters. How'd you get that? A third of 30 centimeters, yeah. All right, so this angle here. Here's a little bit of fucking fun geometry for you. That angle there, theta, is the same as that angle there, theta. And same thing over here. I'm assuming we're bending them up at the same angle. If I do a little line like that, that's 10 centimeters. This is some height we don't know. That height is actually what's changing, right? So this length here is changing. This length is changing as it bends up straighter. Holy shit, I completely rolled off. It's not flat. As it's like this, the top of my fingers, tips of my fingers are further apart, but as I bend them up, they become, tips of my fingers are further apart, but as I make the angle more vertical, the tips get closer. So that length's changing, and so is the actual height. Because as that rotates up, it gets a little taller. So L is changing also. So maybe we can find something where with L in terms of H. Is there something that we can find with L in terms of H on that picture? Well, L is the whole thing, so maybe let's just call this X. How do we do that? And we want to know what angle to choose. So we should have go for something with theta in it. Does anyone know the volume of a trapezoid or the area of a trapezoid? It's actually kind of neat.
Not just, think, have a good rectangle, the same rectangle.
Yeah, you gotta, like, it's easier to shift, it ends up being 1/2. The sum of both or some shit like that. The way I remember it is we grab this piece and we fill it in over here. And so the height stays the same. And this happens to be the average of the, like, if this is B2 and this is B1. This semi-length is the average of the two. This is 1/2 B1 and B2. Or as we got it pictured, it's B2 plus X. So the area is B, well, the B's are the same because it's going straight up. B plus X times H. And what is B? Do we have any? We don't have H, we don't have X, but we have B. B is 10. And we want to end up with a dA d theta if we can. I don't know if we're going to be able to do this, but we're going to try. We might have to do this in multi-parts. Actually, we got that triangle, don't we? I can find X and H in terms of theta. So in terms of theta, that's my right angle there. It doesn't look like it, but in terms of theta, X is, if we do cosine theta is adjacent over hypotenuse, which is X over 10. So X equals 10 cosine theta. And sine theta is opposite over hypotenuse, which is H over 10. So H equals 10 sine theta. I think we're getting somewhere. I feel it. I had no idea we were going to make 3 equations here. You guys, does what I did make sense? So you got to kind of like go, where can I get these pieces? I don't want X. What motivated me here is I wanted a change in theta, and I didn't have theta present. If I can write this in terms of theta, this equation becomes a whole lot easier. So what information did I have for my picture where I could rewrite X and H in terms of theta? That was the motivation behind that. And it was all about the goal. The goal is what drove me. That changes A to be 10 plus 10 cosine theta times 10 sine theta. There's an equal there that I don't have. If you factor out a 10 out of the first one, you've got 1 plus cosine theta. You factor out a 10 out of the second one, you've got 10 sine theta. I have seen students on the test leave shit like that, where the numbers are like, the coefficients are embedded throughout, and don't leave shit like that. Even if that was your final answer, that's what you got. Clean that shit up. 10 times 10 is 100. We have 100 times 1 plus cosine theta times sine theta. I think this will be easier to take the derivative of than leaving the tens in there. So dA d theta is going to have 100 times whatever these derivatives are. So f of theta is 1 plus cosine theta. G of theta is sine theta. And we need f prime of theta and g prime of theta. Because we want to plug in f prime g plus fg prime. So what's the derivative of f prime of theta? Or what's the derivative of f?
Negative sign.
Negative sine. Excellent. What about g? Cosine. All right, let's plug in what we got. F prime is negative sine times g, which is sine, plus f, which is 1 plus cosine, times g prime, which is cosine. And we want to set that equal to 0. I've got negative sine squared plus cosine theta plus cosine squared theta. I want that to equal 0. God damn, shit just gets trickier and trickier. All right. I got my derivatives right? We did everything right? Let me just double check before I go through all the fucking painful trigonometry algebra here. F was 1 plus cosine, and we took the derivative, we got negative sine. G sine goes to cosine, and F prime G, negative sine sine, and then 1 plus cosine times cosine. Okay. All right, so. Well, we can divide by 100 right away. Let's get rid of that 100. Don't need it. All right, I don't like having the sines and the cosines in there. I really don't. So, do we have any formulas that will allow us to swap them? Like I have a cosine theta and a cosine squared theta. If I can write this in terms of cosine theta, this gets easier. You guys know any formulas for that involve sine squared that lead to cosine?
Identity,
Pythagorean identity, excellent. What is it?
sine squared plus cosine squared.
Yep. So if I wanna get sine squared by itself, I'll just subtract cosine squared. And if I want negative sine squared theta, I just change the signs. This becomes -1 plus cosine squared theta, or I'd probably put it like this. And we're gonna take that, we're gonna replace this for this. And we're gonna get cosine squared theta -1 plus cosine squared theta plus cosine theta equals 0. God damn, this problem's got it all. This is the rat fuck special. Now what? Well, let's group them together. Any ideas? What form does this look like?
Looks like a quadratic formula.
It looks like a quadratic formula, right? Let's make it a quadratic formula. How can I make this a quadratic formula?
Substitute x for cosine.
I'm gonna use u because I had x in the problem.
Okay.
But yes, exactly. I used u, x in the problem, we'll use u, excellent. So we've got 2u squared plus u minus 1 equals 0. This factors needs to multiply to -2 and add to 1, so 2 and -1. 2u squared plus 2u minus u minus 1 equals 0. I got 2u times u plus 1 minus 1 times u plus 1. I get 2u minus 1 times u plus 1 equals 0. So I set these equal to 0 and I get u equals 1/2 or u equals -1. What a great problem. It's like fucking makes you pull out some algebra, trigonometry, all sorts of shit going on here, right? More trig than algebra. All right, now what? We're almost there.
Would you write that back in terms of cosine?
Got to do that. We did not start with u. We need to, and we didn't even want u. We wanted theta. So we've got cosine theta equals 1/2, or cosine theta equals -1. So what are my options for theta? What's the degrees? You don't have to give me the radians. What cosine angle makes cosine 1/2? Ooh,
60.
it's 60. 60 degrees is the only one. Let's take a look at the unit circle. We could do -60, but that doesn't help us any. 60 degrees is right there. And we want cosine to be positive. The right quadrants are the only spots. But here we're like negative. I don't want -60 degrees. That's why bother? That just means we're bending it the other way and making the shape the other way. What about that one? Cosine theta equals -1. What angle is that?
Pi.
It's pi or 180 degrees?
Oh, yeah.
I don't want to say slash, I might think it's division. This is pi over 3. 60 degrees is pi over 3. 180 degrees is pi. If I'm helping a youth group, I'm probably going to use degrees. Because I know they don't know what a fucking radian is. How can we make sure that's the max? We could plug it, we plug it into what?
60.
Like here or like what like which equation do you want me to plug it into?
First one, like the third one.
Okay, the derivative one, we should end up getting 0 if we plug in 60, but let's check it. Because that's how we found it. Come on, give me a blank page. There we go. I'm gonna switch to that one. That was our last, the shortest one. Actually, I can treat this in its factored form. I can go with 2 cosine theta minus 1 times cosine theta plus 1 equals 0. Just by plugging u back in right there. If I plug in 60 degrees, that's not 0, but this one is. Cosine of 60 is 1/2. 2 times 1/2 is 1. 1 minus 1 is 0. So that will zero it out. So how can we make sure it's a max? If we graph it, it should look something like that, which means the derivative before the value is positive, and the derivative after is negative. So let's do a little sign chart on 60 degrees using this. If I plug in 0 degrees, 0 degrees is less than 60. And we'll plug in 90 degrees. Let's make this easy. Plug in shit that we can compute real quick. Cosine of 0 degrees is 1. So this becomes 2 times 1 minus 1 times 1 plus 1. This ends up being a positive. This is positive. This is positive. This is positive. Cosine of 90 degrees is 0. So this just ends up being -1 times +1. That's a negative. So we showed it goes up as it approaches 60 and it goes down as it moves away from 60. Or it goes past 60. So we did show it's a max. Yeah.
Can I ask why we're using 60 degrees? Instead of 80?
Excellent question. Let's go back to our picture.
Wait. Hold on. That's yours.
It's a valid question.
Right, yeah.
Now that I'm drawing the picture, it may sound kind of silly because you're like, oh, duh.
This is flat.
Yeah, it's just flat. If we go with a full 180, this motherfucker flattens out and we don't have any volume area. It's always worth asking. You probably weren't the only one wondering why.
I get it. See it.
Was that not fun? How much would change if we decided to do this as volume? Does anyone need this up? I'm gonna put the old pages back and like scan through them and discuss if we left it as volume. Okay, back, oh my god, this was 4 pages long in writing. So that was our picture, that doesn't have any work. Our area would have just been volume, but volume was times a fixed length that wasn't changed. It was times 3 meters. Which is 300 centimeters. So in terms of volume. This would have been 300 centimeters times A. That's all that would have changed, and that just means multiplying this by 300. I don't think our problem changed. I think we kept the simpler form by doing area. Because the only thing it added was a constant multiplier. And that doesn't change with the derivative. So definitely easier as area. It's just got smaller numbers. All right, that's it for lecture. I have your exams if you want them back. Otherwise, you're free to GTFO, or if you got any questions, I'm happy to answer them.